In early February 2026, the South China Morning Post published a report citing sources close to China's commercial aviation industry, describing something genuinely unusual, a regulatory approach that, if it works the way COMAC and Chinese aviation officials are hoping, could meaningfully ambitious aircraft programs China has ever attempted. Specialists from the Civil Aviation Administration of China, the country's own aviation regulator known as the CAAC, had begun proactively embedding themselves directly inside the design and development process for COMAC's wide-body C929 airliner, participating in design reviews, offering technical feedback, and, most strikingly, moving some certification-related assessments forward while the aircraft itself was still taking shape on the drawing board, rather than waiting for a completed design to be handed over for review only after engineering work had fully wrapped up. The report noted this level of proactive regulatory involvement went beyond what typically happens even in China's own aviation industry, let alone what Western manufacturers have ever experienced with their own considerably more arm's-length regulatory relationships. A source close to the matter described the joint work between COMAC and its own regulator as suggesting a genuinely accelerated pace, a level of direct regulatory involvement in an aircraft's design phase that goes considerably beyond how earlier Chinese commercial aircraft programs, including the C919 narrowbody, currently flying passengers across China, were actually developed and certified. Boeing and Airbus, both companies that have spent decades operating under the more traditional Western regulatory model, where a manufacturer typically completes its own design work before submitting it for independent arm's-length review by the FAA or EASA, are watching this specific procedural shift with genuine interest. Because if China's own domestic certification process for the C929 really does move meaningfully faster as a direct result of this parallel track approach, it would represent a genuinely significant structural advantage neither Western manufacturers' own regulatory relationship currently allows them to replicate. To understand why this specific regulatory strategy matters so much, and why it represents such a departure from how COMAC's own previous aircraft programs actually unfolded, you first need to understand the tangled, genuinely dramatic history behind the C929 program itself. The aircraft didn't start out as a purely Chinese effort at all. It began in 2017 as a joint venture between COMAC and Russia's United Aircraft Corporation, initially designated the CR929, with the C standing for China and the R standing for Russia, envisioned as a genuinely shared wide-body program with engineering work split between design teams in Shanghai and Moscow. For a few years, the partnership moved forward, if slowly, with high-speed wind tunnel testing using a scaled fuselage model completed at a Russian Aerodynamics Institute by December 2019. Then Russia's full-scale invasion of Ukraine in February 2022, and the sweeping international sanctions that followed, fundamentally destabilized the entire arrangement. China quietly began distancing itself from Russia's proposed PD-35 engine, originally intended to power the joint aircraft, and by August 2023, United Aircraft Corporation's own chief executive, Yuri Slusar, publicly confirmed Russia's withdrawal from the program entirely. 3 months later, in November 2023, COMAC formally rebranded the aircraft as simply the C929, officially confirming it was now being developed entirely independently by China alone. The R for Russia had been quietly deleted from the aircraft's own name, along with any remaining pretense of the shared binational ambition the program had originally been built around. Freed from that Russian entanglement, but also freed from whatever shared engineering resources and institutional knowledge Russia's own aerospace industry might have contributed, COMAC has spent the past several years rebuilding the C929 as a fully independent Chinese program. And the aircraft has moved through several genuinely concrete milestones since that formal 2023 split. The baseline C929-600 configuration targets roughly 280 passengers in a two-class layout with a range of 12,000 kilometers, positioning it as a direct competitor to the Boeing 787 Dreamliner and the Airbus A350neo, the exact same wide-body segment currently dominating long-haul international routes across the globe. At the Zhuhai Air Show in November 2024, Air China signed a preliminary agreement to serve as the aircraft's launch customer, a genuinely important commercial signal for any new aircraft program, since a committed initial buyer indicates real industry confidence rather than the aircraft existing purely as an abstract national prestige project floating on government subsidy alone. By early 2026, the program had entered its detailed design phase, and at the Singapore Air Show that February, COMAC signed a letter of intent with Aviation Systems, a 50-50 joint venture between America's GE Aerospace and China's own Aviation Industry Corporation, to supply the aircraft's core avionics processing system, essentially the electronic brain that will handle flight management, navigation, and systems integration throughout the completed jet. Preliminary wind tunnel testing had also begun in the months leading up to that announcement, marking one of the first genuinely tangible steps toward validating the aircraft's actual aerodynamic design rather than simply its paper specifications, though COMAC has not publicly disclosed whether that specific testing involved full-scale models or partial airframe sections. On the manufacturing side, fuselage specialist Warui Aero has committed to delivering the C929's first middle fuselage section by September 1st, 2027, a concrete, datable production target that gives outside observers a genuine, verifiable checkpoint to measure the program's actual progress against in the coming months. Despite all of that genuine forward motion on the airframe, avionics, and manufacturing side of the program, the C929 continues facing one enormous, still fundamentally unresolved question that no amount of accelerated regulatory involvement can actually solve on its own: exactly what engine will eventually power the aircraft. China's stated ambition has always been for the C929 to enter service using a genuinely domestic Chinese engine, avoiding the same kind of foreign dependency that has repeatedly complicated the C919 narrow-body program, an aircraft that remains reliant on CFM International's LEAP 1C engine, built through the joint venture between America's GE Aerospace and France's Safran, a dependency that turned genuinely dangerous in 2025 when American export controls temporarily suspended engine component supplies to Chinese aircraft programs entirely. The domestic engine China has been developing specifically for the C929, known as the CJ2000, achieved a genuinely significant technical milestone in January 2026, reaching 35.2 tons of thrust during test stand evaluation, placing it in the same general performance class as established Western wide-body engines like the General Electric GEnx 1B and the Rolls Royce Trent 1000. That result represents real, independently observable engineering progress, the first time a domestically developed Chinese engine has crossed into genuine wide-body performance territory at all. But as of early 2026, COMAC still had not formally announced the CJ2000 or any other engine as the confirmed power plant selection for the C929, an unusually late-stage gap for a program that has already locked in an avionics supplier, a fuselage manufacturing timeline, and a launch customer, and one that industry analysts have specifically flagged as the single biggest remaining technical obstacle standing between the C929's current design phase and any realistic path toward actual commercial service. That specific engine uncertainty is precisely why the CAAC's decision to embed itself directly into the C929's design and certification process from this comparatively early stage carries such genuine strategic weight, rather than functioning as a purely cosmetic or symbolic gesture. Aircraft certification is, at its core, an enormously time-consuming process precisely because regulators need to independently verify an aircraft's safety across every single major system: structural integrity, avionics, hydraulics, fire suppression, emergency systems, and, critically, on the engine itself, typically only after a manufacturer has already finalized its own design and submitted a complete package for review. That traditional sequential model, design first, then certification review, is exactly what has repeatedly stretched Western certification timelines for entirely new aircraft programs into multi-year, sometimes near-decade-long processes, and it's exactly the model COMAC's own C919 narrow-body program followed, contributing directly to that aircraft's own 8-year delay between its originally planned certification date and the moment it actually achieved full Chinese type approval in September 2022. By instead moving CAAC specialists directly into the design process itself, reviewing and providing feedback on individual systems and components as they're being developed, rather than waiting for a fully completed aircraft design, COMAC and its own regulator are attempting something that could, in principle, meaningfully compress that traditional multi-year certification bottleneck, catching potential safety or design issues early enough in the process that they can be corrected during initial engineering work, rather than requiring a costly, time-consuming redesign. After the fact, once a supposedly finished aircraft has already failed a late-stage regulatory review. Whether that specific procedural innovation actually delivers on its promise remains, as of the most recent reporting, a genuinely open question, and it's worth being clear-eyed about the reasons for skepticism sitting alongside the genuine reasons for interest. COMAC's own historical track record across virtually every previous aircraft program offers considerably more evidence of chronic delay than of accelerated delivery. The C919 itself missed its originally targeted 2014 first flight by 3 years, missed its originally targeted 2016 certification by 6 years, and has continued missing its own publicly announced annual delivery targets consistently since entering commercial service, closing out 2025 with just 41 total aircraft delivered across its entire product line, well short of the roughly 75 C919 units the company had originally targeted for that year alone. Independent aviation analysts at IBA have projected that even with steadily improving production rates, COMAC likely won't reach anything resembling a globally competitive annual delivery pace until sometime around 2030, when the firm forecasts deliveries could reach roughly 90 aircraft annually, a meaningful improvement over current output, but still a small fraction of what Airbus alone delivers in a single year today. Against that specific backdrop of a company with a genuinely well-documented history of missing its own announced targets by considerable margins, COMAC's current C929 timeline, targeting a type certificate by 2032 and first commercial service by approximately 2035, deserves the exact same measured skepticism industry observers have learned to apply to virtually every previous Chinese aerospace milestone announcement, regardless of how genuinely innovative the underlying regulatory strategy driving that timeline might actually be. Still, the specific mechanism COMAC and CAAC are attempting here deserves serious attention precisely because it represents a genuinely different theory of how to compress an aircraft certification timeline, one that doesn't rely purely on working faster within the existing sequential model, but instead restructures the fundamental relationship between manufacturer and regulator into something closer to continuous, real-time collaboration throughout the entire design process. That structural advantage, a domestic regulator with direct authority to shape and expedite the review process, working hand in hand with a domestic manufacturer answerable to the same national government, simply doesn't exist in the same form for Boeing or Airbus, both of which must navigate arm's-length relationships with independent regulators, the FAA and EASA respectively, that operate under statutory mandates specifically designed to maintain regulatory independence from the manufacturers whose aircraft they're evaluating, precisely to avoid exactly the kind of blurred lines between developer and approver that critics could reasonably raise concerns about regarding China's current C929 approach. Whether that closer, faster Chinese regulatory relationship ultimately produces an aircraft that international regulators outside China, including the FAA and EASA specifically, are willing to trust and independently certify themselves is an entirely separate question from whether it helps COMAC hit its own internal domestic certification targets faster, and it's a question that will only be answered years from now, once the C929 design is actually complete and Western regulators begin their own independent review process, a process COMAC's C919 experience suggests could still take years, even after Chinese domestic certification has already been achieved. The C919's own certification experience offers a genuinely useful point of comparison for understanding exactly what COMAC is trying to avoid repeating with the C929, since it illustrates just how punishing the traditional sequential certification model can be even for a comparatively simpler narrow-body aircraft. Beyond the 8-year domestic certification delay already mentioned, the C919 still has not secured either FAA or EASA approval as of mid-2026, years after entering commercial service within China itself. EASA completed a 4th round of on-site technical assessments back in August 2024, and by November 2025 had progressed to sending its own test pilots to Shanghai for hands-on verification flights, genuine forward movement. But European officials have been candid that full certification could still take up to 6 years, from the point serious evaluation began, pushing realistic European approval into the back half of this decade at the earliest. FAA certification, meanwhile, is not even being actively pursued as of early 2025, a direct casualty of ongoing U.S.-China trade tensions and COMAC's own placement on a Pentagon list of companies with alleged military ties. That specific history, a narrow-body jet that took 8 years longer than planned just to achieve domestic approval and still lacks international certification years into commercial service, is exactly the kind of drawn-out timeline COMAC is explicitly trying to avoid repeating with its considerably more ambitious, considerably more technically demanding wide-body program. Exactly what Boeing and Airbus stand to lose if COMAC genuinely does manage to compress its wide-body certification timeline meaningfully. The Boeing 787 and Airbus A350, the two aircraft families the C929 is explicitly designed to compete against, together represent one of the most commercially lucrative segments in the entire global aviation market. Long-haul, twin-aisle jets capable of connecting major international hubs across intercontinental distances, a market segment airlines worldwide will need to keep replenishing and expanding for decades to come as global air travel demand continues growing. Neither Boeing nor Airbus has historically faced any serious competitive pressure in this specific wide-body category from any manufacturer outside their own two-company duopoly, a market structure that has persisted essentially unchallenged for the entire modern history of commercial jet aviation. A genuinely credible Chinese wide-body competitor, even one initially confined to the domestic Chinese market, and a handful of allied Southeast Asian carriers, would represent the first serious crack in that decades-long duopoly's grip on the wide-body segment specifically. And Chinese officials have made no secret of viewing that outcome as a core strategic objective, extending well beyond simple commercial competition, tied directly to broader national ambitions around technological self-sufficiency and reduced dependence on Western aerospace suppliers across the board. COMAC's outreach efforts at that same February 2026 Singapore Air Show extended well beyond simply signing the Aviation Systems avionics deal, with the company specifically directing attention toward potential Southeast Asian customers for the C929, alongside its ongoing narrow-body sales push, delegations from Indonesia among those reported to have sought detailed information about the wide-body program during the event. That outreach pattern mirrors almost exactly the same regional strategy COMAC has already been pursuing with the smaller C919 narrow-body, courting carriers in countries with existing economic and diplomatic ties to Beijing before attempting to break into markets with less direct Chinese influence or considerably more skepticism toward Chinese-built aircraft. Whether that same regional playbook, offering attractive terms to airlines in China's near abroad while pursuing a domestically accelerated certification path rather than immediately chasing Western regulatory approval, can actually work for a wide-body aircraft flying considerably longer international routes than the narrow-body C919 typically operates, remains a genuinely open question, since wide-body jets, by their very nature, tend to fly the kind of long-haul intercontinental routes that make international certification acceptance, in markets well beyond Southeast Asia specifically, considerably more operationally essential than it is for a narrow-body aircraft that can, at least in principle, sustain a viable business flying purely regional or domestic routes within a more limited geographic footprint. Under Chairman He Dongfeng, who has overseen the company since 2017 through exactly the kind of sustained multi-program build-out the current C929 certification strategy represents just the latest chapter of. Under his direction, COMAC has simultaneously reorganized C919 program management following that aircraft's own repeated flight test delays, pushed the narrow-body jet's domestic certification through to completion. In September 2022, restructured the smaller ARJ-21 regional jet under its new C909 commercial branding in late 2024, approved a formal design freeze for the C929 widebody, and greenlit preliminary design work on an even larger, longer-range aircraft, tentatively designated the C939, intended eventually to challenge the Boeing 777 and Airbus A350 in the largest wide-body category still further down the road. That parallel, multi-program build-out reflects a deliberate corporate strategy of pursuing narrow-body, wide-body, and eventually large wide-body aircraft simultaneously rather than sequentially, betting that sustained overlapping investment across multiple aircraft categories will eventually produce a genuinely comprehensive Chinese aviation manufacturing capability spanning the full range of what Boeing and Airbus currently offer, rather than COMAC remaining permanently confined to competing in just one narrow segment of the broader commercial aircraft market. COMAC secured a 44 billion yuan incremental capital injection in late 2024, specifically to help fund this kind of expanded multi-program ambition, a figure equivalent to several $billion in additional state financial backing directed specifically at accelerating exactly the kind of parallel development effort the C929's current certification strategy represents. There's a deeper strategic logic worth understanding behind why China has been willing to invest this heavily in restructuring its own certification process, specifically for the C929, rather than simply accepting the same multi-year international approval timeline every previous new entrant into commercial aviation manufacturing has historically had to endure. A domestic certification process, capable of moving meaningfully faster than the traditional Western sequential model, would give China something considerably more valuable than simply an earlier entry into service date for one specific aircraft. It would provide a genuinely reusable institutional capability, a demonstrated template for compressing the certification timeline on every subsequent aircraft program China's aerospace industry develops going forward, including the still earlier stage C939 large wide-body program already in preliminary design. If the C929's accelerated certification approach genuinely works as intended, China would have effectively solved, at least for its own domestic regulatory purposes, the single structural bottleneck that has repeatedly proven to be the most time-consuming, most unpredictable phase of developing any new large commercial aircraft. A bottleneck that has cost COMAC years of delay on the C919 already, and that continues constraining how quickly any new manufacturer, regardless of nationality, can realistically bring a genuinely new aircraft design to market. That is precisely why Boeing and Airbus, and the broader Western aerospace industry more generally, are paying close attention to this specific procedural development, not because the C929 itself poses any immediate competitive threat, given how far away actual service entry remains, but because the certification methodology being tested on it right now could end up mattering considerably more and lasting considerably longer than any single aircraft program built using it. What makes this entire story genuinely worth following closely over the coming years, rather than simply another entry in a long list of ambitious but ultimately underwhelming Chinese aerospace announcements, is the specific combination of factors converging around the C929 right now. A launch customer already secured, an avionics supplier already under contract, a concrete fuselage delivery date already set for 2027, a genuinely novel regulatory strategy explicitly designed to compress the certification timeline that has historically been COMAC's single biggest bottleneck. And sitting beneath all of that genuine forward momentum, one enormous, still entirely unresolved question mark hovering over the aircraft's own engine. The single component every previous major aircraft program, Chinese, Russian, or otherwise, has found to be the hardest, slowest, most technically unforgiving piece of the entire puzzle to actually solve. Boeing and Airbus didn't necessarily expect China's own aviation regulator to start embedding itself directly inside COMAC's design process this early, or this closely, and that specific procedural shift genuinely could shave real-time off a certification process that has, for both American and European manufacturers alike, historically taken the better part of a decade to complete for an entirely new wide-body design. Neither company has ever had to compete against a rival benefiting from this particular kind of structural regulatory advantage, a domestic certification authority functioning less like an independent watchdog and more like an embedded development partner. And industry analysts at both companies are reportedly watching the C929's progress specifically to see whether this approach genuinely translates into a faster path to market, or whether it simply front-loads certification work that will still, ultimately, need to be redone or independently verified once the aircraft eventually seeks the kind of international regulatory approval that would actually let it compete for orders beyond China's own borders and its closest regional allies. Whether that faster domestic certification path actually translates into a genuinely competitive, internationally trusted aircraft entering service anywhere close to COMAC's current 2035 target remains an entirely separate, considerably harder question. One that will ultimately be decided not by how quickly Chinese regulators can review paperwork, but by whether China's aerospace industry can finally solve the one problem that has quietly defeated every one of its previous ambitious aircraft programs, building an engine genuinely good enough and genuinely reliable enough to actually put in the sky.